Alright, so, no math class tomorrow. Plan book should be filled out today and tomorrow. Now, I will apologize, like, genuinely. This is more than I like to assign you in one night. This is 10 problems. 0 through 9. I know you're like, oh, wait, 9, it's 10 problems. It's, like, not crazy. You guys are the accelerated class. This would be broken into 2 days in the regular Math 7 class. Or not regular Math 7. So it is more problems than I normally assign. We have plenty of time to get it done. I will not be checking math journals until at earliest on Tuesday of next week. Probably more so Wednesday or Thursday. So we'll talk about when we can take our assessment next week. We got to do a day of closure for sure. I avoid Monday assessments like I avoid needing to run. So I don't like running. I like pretty much every other athletic activity. I mean, if I'm playing soccer, I don't consider that running. That's like jogging. Yeah. All right. So moving forward, we have a decent amount to get through there. I think we can get through it pretty quickly. On the fact of us having a decent amount of homework, if we can get through the lesson, I would happily give you time to work on homework, and we could actually work on some problems together. Hello. It's really arithmetic properties. And how we say that, people can emphasize it two different ways. You can say arithmetic or arithmetic. But here saying arithmetic properties sounds a little weird. Saying arithmetic, whichever, is just how we work with numbers, how we combine them. Add, subtract, multiply, divide, all those sort of things. Geometric, actually I misspoke a little bit. Arithmetic is more addition, subtraction. Geometric is more multiplication, division. So Juno, apparently Mrs. Gordon loves that name, Juno was working on simplifying this expression. I know, he exclaims. It must equal 30 because 20 plus 10 is 30. As a team, reason, is Juno correct or does he need some redirection? Take a couple minutes. If you get done with that, obviously move on to 13, and if you get done with that, 14, whatever. Is it still like you can't bend it? So you just leave it? Yeah, don't push it. Let it heal on you. Probably make you feel any better, but I've been practicing recently doing the pull-ups with just fingertips. I did one in the doorway to the family room, and this is everybody's like, what? Like just the metal doorway. My gym's just closed right now. I work at Lifetime in Dublin. Alright, about a minute. We'll bring this back together. Alright. Yeah. Are you actually ready? Wait. How did he get? Okay, so I only got one. Get it now. You're a genius. Wait, so I should break all. No. All right, I'll take volunteers to start us out today. Mina, what do you think? What would you say to Juno?
Okay, so Juno is correct, and he got 20 plus 10, because he did 24 plus negative 4 is 20, and then 7 plus 3 is 10, and then he just added them together.
We saw numbers that will work together easily. And that's how he got his 20 and his 10. So it's that grouping where we mentally say this will work easier than doing it in order. Now, if we actually talk about him rewriting the problem, like kind of changing the order, what is this called when we change the order of addition or multiplication? The commutative property. So if you don't yet have that in your brain real solid, and it's right here in 13. The commutative property says in addition and multiplication, we can move things around however we want. What's that again, Alana? What's that property called? Yeah, you're not with me at all, dear. Commutative, write it down. Come on. I don't like calling you out, but when it's obvious, it's obvious. Moving dear, what's up?
But you couldn't switch it around when there's parentheses.
What do you mean? What do you mean couldn't switch around? There's parentheses here.
Yeah, but like if you had two numbers.
This was unnecessary. I don't know why I wrote that parentheses. Sorry.
If you had two numbers in one parenthesis instead of parentheses.
So like 3 plus that. I can't do.
No. More numbers outside.
So we'll see some examples where we start to deal with things like that. And by the way, this you can do. As long as it's addition, you can do this. What Bouvendier is talking about is a more complicated situation, which we will see. So, our commutative property, and if you're ever in the textbook, you can click on blue words. Oh, I'm not in the textbook, sorry. If you're in the textbook, you can click on blue words and the definition pops up. Textbook's up there, though. And the associative. Now, we haven't really talked about this yet. Associative. The associative property. What does it mean to associate? Well? If you are in an association.
You're part of something.
You're in a group. So, the associative property says that we are allowed to change groupings. So, associative says, and we're going to write this down in a simple way. So, in your notes, please, let's practice spelling it. It's that bad word. And then, associative. I mean, come on, we all thought it.
No, I didn't.
So associative property, really, to help you remember it, is just we are allowed to change groupings. And notice that that one is of addition. So associative property works for addition. Addition. So if they say associative property of addition, question is there an associative property of multiplication, of subtraction, of division? So what do you think? Talk for a minute. Would this work with other operations? Go ahead. You gotta be able to justify why. Give me an example. If you're gonna say it does or does not, you gotta give me an example. 13, I think. Yeah, 113. Yeah. You look like you're thinking about something. As long as you're okay. Oh, backwards. Have you guys figured out if this will work for anything else? No other audio. So, if you're testing this, I'm not giving you an answer yet. If you're testing this, we have to have groupings happening, right? So if I had 3 times 4 times 2, is that equal to, is the question to ask, 3 times 4 times 2? Change the groupings. If I have 8 divided by 2 divided by 2, is that the same as 8 divided by 2 divided by 2? Play with it. Try some examples. Do one with subtraction. Oh my goodness, what?
That one's 2 and that one.
So I'm hearing some realization sounds. Like, oh, Those like awkward body release noises. What's 3 times 4? 12. Times 2? 24. What's, bless you. What's 4 times 2? 8. What's 3 times 8? 24. Does it work for multiplication? Yeah. These are equal. It does work. 8 divided by 2. Divided by 2? 2 divided by 2? 8 divided by 1? Does this work? No. 10 minus 7. Did you just say 4? What's 3 minus 3? 7 minus 3? 10 minus 4? Hold on. Ava's got it. Say it louder.
It doesn't work for division and subtraction, but it does for addition and multiplication.
So in our notes back here, where we wrote associative property addition and multiplication. This is the basis of proof. When we want to make a statement mathematically of what works or doesn't, we have to give examples that show why. We can prove this holds true for multiplication. Any situation like this where we change groupings, it will hold. We can prove it falls apart with division and subtraction. How?
The weird thing is that when it only works when you're making a number bigger, and it doesn't work when you're trying to take away stuff.
Now, I will push back on that and say, what if I multiply with a fraction? So, be careful with those general statements. I like where you were going with that. Multiplication makes things bigger. Addition makes things bigger. But we can add negative numbers, and we can multiply with fractions. So be careful with those statements. I love your thought process, though. So associative works, addition and multiplication. Awesome. So, let's try these. Play with these for a little bit. Work with your teams to try to accurately solve all of these expressions and answer these questions. I'll give you probably 4 or 5, longer if you need. I don't know how long this is going to be. You don't need. Together. Ah, nice.
Does moving matter? Left to right. 7 minus 2 is 5. Yes, it does.
You are flat. Yes. Luna.
Well, actually, if you're in a problem that has a subtraction then addition, you go left or right. And so you did 7 minus 1 is 5.
No, we're not rewriting the order. We're just adding
Okay,
Did you hate me? You know you have a textbook, right?
All stars.
Up here for 2 seconds.
What? Okay.
Gemdas. Why'd I write Gemdas? Have we talked about this in here yet? And why'd I write it how I did? So I'm with hands, right? We have hands.
Yes.
Why am I blanking? I know you're just crap. Dude, help me out.
Alice.
Why Gemdas?
because you don't like same parentheses, so you put grouping.
Ah, grouping symbols. Now why the weird beside each other? Keep going.
For like multiplication, division, you do them like at the same thing.
Ah.
Adding and subtracting.
The way they used to have you write it like a ladder is false. These are the same step. These are the same step.
Why did you never teach us the wrong things a lot of times? They also say people are. And then
Algebra, just limit everything.
Because when things are easy, they don't have to be so specific.
I'm done, guys.
When you learn the practice, you're like,
We'll play that if we have any like days right before vacation. It's like riddles. What's what?
I'm not 12.
You're not.
Yeah.
It's 12 and up.
Wait.
You're one. You can't play.
Yeah.
All right. Let's go cards now.
Let's go, cards. Yeah.
Alex, how do I solve this first problem here?
Which Alex?
Sorry, Alex B.
First off,
This is why I couldn't remember your. We have too many Alexes here.
Yeah.
No, we have way more than that.
no, we don't.
Alex Cooper, Alex B, Alex K.
That's it. No, that's it.
I think we have more. Okay.
Alex
Alex B, how do we solve this?
First off, you just, since subtraction and addition, think they're like on the same level,
Yep.
you just go from left to right.
Perfect. 7 minus 2 plus 4. Sweet. So wait. So Alex said just work left to right. Which of these, or are they both, correct to represent what process we took?
The first one is. The second one is not.
Why?
Because if you do 2 plus 4 first, it's 7 minus 6, which equals 1, which does not equal 9.
Here is why associative doesn't work when subtraction's involved. If you move where things happen or in what order they happen, you've modified the situation and you change the result. You've literally changed what's happening. Here, we just cleaned it up. We said, yeah, that has to happen first. Those parentheses are unnecessary. Sorry, is that what you were going to say? So go ahead, drop it on us. I don't care. Okay, here's. Now that you'll never forget that, let's move on to C. Now, I really hope that we're good here. C, Oliver.
Yes.
So the first one, we already processed through this. What about this? Would this be the same?
No.
What would this give us?
It would give us a -1.
It would actually give us -1. 2 minus 7. Hey, guys, with us, please. Thank you. -5, then plus 4 still leaves me at a -1. Not at all the same. So we cannot change. What property is that applying? What moves numbers but doesn't have parentheses? Commutative. I have nothing funny or anything to memorize that, but commute means move. Commute, move, commute, move. Now, this is what's dangerous. People will look at this and say the parentheses moved, it was commutative. Parentheses moving is associative. Numbers moving is commutative. Okay? I, and I. Zach, help me out. How do I solve it? Notice that I said Zach? Nice. Sweet, so we end up with 8 plus 4, and we get 12 as I solve it left to right. As I think this through left to right in I, Naya, help me out. Notice how I said your name.
Oh! Okay, and
I.
you put the 2, I put the 2 on 6 in parentheses, which equals 8, and the 3 on 5.
Never!
Why?
Because that's wrong, for real. I'm not just being dramatic. So, now, I would love to use that as an example of what not to do. So, sorry that you went the wrong route, but there were no parentheses here, so be careful introducing them. Naya said, I'm going to put those together, add them, and know that this is, and then I get 0.
What? No.
Or, sorry, that's negative. Either way, this 2 is not positive. That 2 cannot combine with a 6 acting positive. He's not positive. He's a bad guy. Because there's a minus in front of him. So we have to be very specific about working this left to right.
What, is it a negative or a minus?
Yes, it's either. You can add. Now, hold on. Another way to look at this is 3 plus -5 plus -2 plus 6. Now it's all addition. Now we can commute the order.
Whoa.
But those parentheses are not grouping any operations. They're just there because of the negatives. Now we could commute it. I haven't moved anything, actually. But now we could because it's all addition. I made these negatives instead of minuses. How it is now, because we want to be able to solve it that way. Just work it left to right. What's 3 minus 5? -2. Go down 2 more. -4 plus 6. +2. Because these make -2, -2 make -4, then +6 makes +2. Zin, help me out on I.
Yeah. Well, because because it starts out with 7 and you're subtracting 3 and you're subtracting 2, you could just, of course, take 3 from 7 and get 4, and then take 2 from 4 and get 2. But because, if you want to make it a little
here's what you just thought through. Zen, in a quick thought process, said, well, if I subtract 3 and then subtract 2, I'm really subtracting 5 in total. So since these are both negatives, I could really combine them, say that, and say that. Now we can, or work it left to right. Cool? Different ways to get to Florida. If we end up at Disney, we're still good.
Yep.
115. Now, be very careful. We've discussed the fact that you can't just throw in parentheses wherever you want, and that you cannot just change the order however you want. So be careful. Juno has this idea, right? Now, I've already introduced this idea to Juno, hence how he has it. He wants to rewrite each of this so it's only addition so that we can then apply commutative property. Play with these. There's a multiplication also in B. Play with these for a couple minutes. See if you guys get the same answers. He wants to make it all addition. I'm not looking for answers right now. I'm looking for you to talk about it. I don't know. Ask your team. You know I'm right. One of our previous students was at home talking to parents one night. Science. But it just seems like Mr. Fielder doesn't really know what he's doing. Because we're trying to get you guys to discover the learning. He was acting very dumb that day. So it was very funny. Just seems like Mr. Fielder doesn't know what he's doing.
Okay, and then one more thing.
As long as whatever this is.
And then you can
I came to hear who said wait. A kid was at home talking with their parents about school, and they're like, I really like science. It seems like Mr. Fielder doesn't know what he's doing. He just acts like, well, we act like that a lot, right? When I act dumb, I'm like, well, can't I just do this? Yeah. Welcome to school. Or life, really, because your whole life you're going to spend correcting people. That's how your personality is. You gotta make sure that you're right. We're missing Izzy, aren't we? Moving deer! If I rewrite A to be all addition, what's it look like? So now it says, then we could change how we simplify. So Ava, why does this change how we can simplify? Now, a lot of you probably don't need to think about this, but Ava's saying, well, since they're both negatives, put those together, and then we're left with the positives. We can put those together. Technically, mathematically, what we've done then is applied the associative property. Because if you are thinking first about the negatives, you move those to first. So we have -4 and -11, and then 17 and 15. What is my combined negatives? 15. What is my combined positives? 32. Now, wait. Ooh, yes, we could. We can also apply the associative property again. Sorry, not associative. Commutative property again. Make this 32 plus negative 15, which then could be rewritten again. Instead of addition, I could, well, yeah, it's 17. But then I can think of this as subtraction, right? 32 minus 15. What's 30 minus 15? 15. And then your 2 extra. Break it up to make it easy. Now, oh, Izzy, you're back. Oh, well, yeah. Did you have time to look at B? No, yeah, I don't want to drop that on you.
Instead of adding 17 and 15 to get 32, you could just use your negative 15 plus your positive 15, which would get 0, and then plus your positive.
We did that, so we're not focusing on that standard right now. I'll write it out for you guys. What was getting said is, yes, we can break our positive into the positive 15 that I need to make a 0, and then what's left, which is 17. There's my 32. And the negative 15. No?
Yeah.
Okay, your head's like going 9 directions. So, if I do this method, then what property do I apply? Because now I change this. You're the one who took me here. You wanted me. You wanted me to write this out. Now we're down this road. Then it becomes 17 plus 15 plus negative 15. What have I changed? So this is associative. Commutative here or associative there. But again, applying those properties that we know we're allowed to do. Done? Gravity works.
I do have a question. This just came to my head. Can you keep emphasizing search? Are you dressing up as a search?
I know. I have not made the.
You should.
I have not made the choice.
You should. I said no. You said you should.
That would be tough. That would involve a costume change. All right. Now fractions. I could have said mixed numbers. Those are even worse. But I mean, we do have mixed numbers. So Maria and can't quite tell, but I'm going to say George.
Jorge.
So, oh, it's Jorge.
Yeah, it's
George.
George. Let's go with it.
So, check out their work. Maria starts the way you see. Jorge has a different idea. So, you guys decide what you think is best. Is anybody wrong here? Are they both right? What's going on in this situation? Really, we're obviously trying to get down to the correct answer, but we want to analyze their methods. Often on tests now, those state tests, there will be, here's a solution shown out. Are there any errors? If so, note what they are. And you have to analyze a done solution. I didn't even. Okay. So check this out. Check this out. See what you guys think. Take like at least 3 minutes. Watch out. I don't know. I was only half listening. Ask your team if you're right. So you gotta analyze: is Maria's solution correct? Is Jorge's solution correct? would they make it in a problem? Yeah, but you can convert. Well, stop. You're in 7th grade. Shouldn't be correcting that Oh, I see what you're asking. Hang on to that question. I want you to kind of like ask it the same way, just louder. Alright, so Ava's analyzing Maria and Jorge, and I think she's taken the Jorge method, but she has a prolific observation. What?
Okay. Well, since like negative 4/3 and like negative 3/4 like cancel each other out.
No, wait. Why? What do you mean?
Because the numerators and denominators multiply the numerators.
What is 3 divided by 3? What's 4 divided by 4? What's a negative times a negative? Positive, right? Opposite of a negative? So Ava would like win my award for the day or whatever. For easiest solution, we don't want to work very hard, right? Ava identified reciprocals multiply to 1, which quickly then means the only thing left to care about is 1 2 5. So Jorge's method will work very well and save us a lot of work when we apply Ava's observation. What was that? Yeah, but she got the right answer. You're right. It's like mowing the grass with scissors. Now hold up. We only have 2 minutes left. In I want hands. In I, who can tell me what we should notice? Nina?
So for 9, it can be 9 once to make it into a fraction.
Ooh, it can be 9 once.
Times 1 9, and so that's -1.
Ooh, so the only thing here that carries is the negative, right? Because 9 on top, bottom, 1 on top, bottom, these will cancel. And really, I hate the word cancel. They'll reduce out to 1. They don't disappear. They don't like. It's if you have 9 cookies and you give them to 9 people, everyone gets 1. But the negative stays because there's only 1 negative. So we will end up with an answer of just -3/8 because those are reciprocals. What? Is there anything that we need to notice about I? This is challenge problem. Bilal, what do you think?
Oh no. Okay. Well, I think I would do.
Hey, how many people in this class are named Bilal? Stop.
We're doing I, right?
No, just I.
Okay. Okay. So I would multiply -5 over 12 times 3/7.
Not the easiest way. You're right. That is a way we can take, but not the easiest way. Who thinks they have the easiest way? Dear? Cross reduce.
So you can cross reduce 3 and 12. Wait, no.
Still not the easiest way. You're right. But still not the easiest way.
You can put them in a parentheses and multiply the positive.
I know it's time to go.
Oh, yeah.
What's 3 times 4?
12.
Group. Here, we will get 12 63rds. And then the 12s will reduce each other out.
So it's
So, Negative 5/63. Make your life easier. With that, mic drop, end of class. What? Essentially, math is here so we can understand things and make things easier. Yeah, that's it. But that's just because it does and I drop things. So, I mean, really, that came